Just a second. Right. Nice. So, yesterday my microphone was not working. As I don't read the comments, I haven't noticed it as well. Happens, right? So, we are at the final day, but I am a bit far away from it. We'll solve this question 9, part 1, and then I'll need to go. Start the counter for 22 minutes. You slide down the fire pole in the corner of the playground and land in North Pole Bay's movie theater. The movie theater has a big tile floor with an interesting pattern. The elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle the movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles. In the big grid they form. Okay. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for two of its opposite corners. They even have a list of where the red tiles are located in the grid. For example, 7, 1, 11, 1, 11, 7, blah blah blah, showing red tiles as hash, character, and other tiles at the dot. The above arrangement of red tiles will look like this. You can choose any two red tiles as the opposite corners of your opposite, like is it like this probably, opposite corners of your rectangle. Your goal is to find the largest rectangle as possible. For example, you can make a rectangle with an area of 24 between this, I don't know, is it 2, 5? 2, 5, isn't it this one? Oh, sorry, it's like the column 3, row 6. Yeah. So this is the column, this is the row. And 9, so it's like, yeah, column, row. Okay, interesting the notation, by the way, but probably it's because like x, y, it thinks, right? So x axis and y axis. No, actually not. So it sees that x, y, and here is 2, 5. This is 9, 7. Anyways, it's not that important. Or you can make a rectangle with area of this. You can even make a thin rectangle with an area of this and this. Ultimately, the largest rectangle you can make in this example has area 50, and it's this. Using two red tiles as opposite corners, I'm not able to speak. What is the largest area of any rectangle you can make? So this area is 6, right? Basically, you're having the difference of x-axis, which is this run. It's like 6, right? Maybe it's like actually the x-axis difference is 5, but you add the 1, so it becomes 6. And for the y-axis, they're like difference is 0. You add 1 and it becomes 1. So 6 times 1 is 6. That kind of logic. And like one like easiest solution that we can take here is, given that you have some positions, you can say, let's calculate, like let's have the unique pairs that we can have, this position to this position. Let's have every other unique combination, and let's calculate their areas, and we can take the maximum of them. That will be the result, right? So that is pretty easy to do, if I'm not mistaken. But what will be the time complexity? Time complexity will be O(n) square, and space complexity will also be like that. Maybe you can avoid it, but you can actually avoid the space complexity depending on the implementation. But the time complexity, as you will be iterating over these combinations, it will be O(n) square, and n is the number of positions that we have. That's the brute force. How can you make it smart? How can you make it identify that? Identify maybe like, maybe by iterating over this list once, perhaps you can find something, or maybe you can sort this list somehow, and after sorting it, you can have some kind of estimation. I don't know. Okay, what if I sort them actually? I can sort, it will become 2, like depending on, yeah, it will start from 2, 3, 2, 5. 7, 7, 1, 7, 3, 9, 5, 9, 7, 11, 1, 11, 7. Basically, you're trying to find, like if I were to put this screenshot here right now, oops, oops, oops. Can you increase? I would like to opacity. I can't. Can I? Yeah, here. So maybe something red. I don't know. Like this is how it will look on the 2D dimension. You can, as I said, you can start from this one, for example. You can calculate the area of this thing and save it. From there on, maybe you can, like, you don't need to move to this one. Maybe you can be a bit greedy, like you can say, okay, let's start with this one. Oh, it's this. From here on, I don't know. Let's go step by step. Let's not implement the complex solution first. Let's implement the base solution, the brute force one. and we'll see if it can't pass. We'll eventually need to solve it. It will probably need me to require a deeper look, which will take a bit more time, probably tomorrow. I can do that, but right now let's do these things. This was the first. Anyways, what was needed. So this is the first one, and this is the. Let's have this input here. So good. Alrighty. So we'll read this input text. We can always get positions. We can call it. We'll give like. Let's have a look at the Q9. Sorry, it will take a path, and it will return a list of tuples, for example, integer, and let's do a pass here. We'll call this get positions with Q9 input underscore txt input test txt, and let's have these positions and print them, and it should open path. It will read it as f. Return right. Okay, so each line for line in f, we can do the following. We can first strip it from the line break, and then we can split it with this symbol. Sorry. And then you can put them into a tuple for tuple value, or like position value, or like for xy, right? We can call it, or like for row. I think it's a bit like it's basically for column and row, right? I would like to keep it in that direction, and then I would like to put them into I would like to create them something like this. For line in F, basically you are stripping the line, splitting it, and then once you strip it, once you split it, you have two values, and then you can say for I don't know, for x in this value, I don't know, can we do, yeah, I think this should work, and return this. Let's go. And no, yeah, so that's wrong. Okay, so we've done something interesting. Maybe something like this. For line in F, you're iterating over it. Okay, yeah, it work right now. So it's 7, 1, 11. So we basically have it right now, but I would like to cast them to integers. And I would like to also, like, maybe we can remember that, like, this is basically the column and this is the row. All right. So we have them in integers right now. Good. From here on, we'll have position pairs. Get position pairs. You can, or yeah, let's do it like this. I like that more. We can pass the positions there. Let's fill this thing up. Let's also print position pairs. Def get position pairs positions. Let's. By the way, it's interesting. I should have done this thing. It didn't complain for some reason. And the return type will be a list again. It will have these coordinates, but again another tuple of them. So I need to copy this thing, this, yeah. Good. Now they're basically for position or for I in range, and positions for J in range, then positions with a slight difference. It should start from I plus 1. We're going to select positions I, positions J, result at append, and result is list, result, return result. Okay, so you first have this pair and then this one to this one, right? And look at this one. This is again the first one to the other one. Now the next one should be 7195. And yeah, it is the case. And the last one should be 23273, this one. So once you have these positions, once you have the pairs, you're going to calculate it. The question asks for the largest area, right? You can say max area. You can have something like this, or let's have it in a more again modular way again and again. Probably in part 2 we'll need to modify them, so I like to have them, keep them modular right now. I will calculate all of the areas and I will put into this array, and then I will take the maximum of it. So areas, you can say it will be the same as this list. It won't be a dictionary. So I will have this as a list, get areas, or like calculate areas, right? Position pairs, and we're going to print the maximum of it. If calculate areas has this position pairs, it was this thing, right? And it will return a list of integers. For a position pair, in position pairs, you can have this areas as a list, or result, whatever it is. We'll return it at the end. And you can break down the position pair. It's position 1 and position 2, right? And then you can say, you can even break it down a bit more. You can say row not actually column 1, row 1, and I'm actually not sure if it will work here, but if you, let's arrays that append, col1, let's say, what happens? I'm guessing Python can do that. Yeah, it does. It does. Cool. Then once we have this, once we have that breakdown, we can calculate the area. The area will be the column 2 minus column 1 times row 2 minus row 1, absolutes of it, and let's go ahead. Area. One thing I'm not, okay, integer times integer is also integer, right? So the result is apparently 436. This matches with the one here. No, because we have to put 1 there. Is it always 1 though? The difference plus 1. Is it like minus 1, the difference? You would like to put this value a bit later on, like this, so that you don't end up. Yeah. Okay. Now 60. Again, I made something incorrect. What is that? Yeah, this thing. Yeah. So, wait, what did I do there? Okay. Start the counter for 5 minutes. Okay, now it's right. Shall we try this thing? Let's see. It can time out, by the way. It didn't. And then I'm going to do it then. That is the right answer. Okay, now I gotta go. I'll continue tomorrow. So that was definitely not the greatest time complexity and space complexity. The space complexity is O(n) squared, just because we are having the pairs and we are storing them in this list. We probably don't need that. Once we have the positions, we can iterate over them without storing them. We can calculate it on the fly and calculate a running maximum, like basically the maximum at that point. You can have this variable. Basically, you'll have one additional variable that you'll need to you need to track. You'll compare with the current one. If it's bigger than that, you'll update the maximum value you have, and at the end you'll return it. So the space complexity is easily reducible to O(1), but the time complexity is O(n) squared, and I don't know, to be honest, how to improve that at the moment. So maybe there is some kind of greedy approach that can be thought of, but I don't know. Like maybe sorting will help. Maybe it can help there. I haven't taken a deep look at it. So probably in the part 2, I'm expecting that there will be some additional difficulty or time limit, or maybe the values will be a bit much to handle, so it won't be easier as this one. But yeah, so far so good. Thank you for joining me on this Friday evening. and wishing you a nice weekend. Bye bye.